Hello everyone, this is Adhish. I'm a grade 10 student from Mumbai. So today's problem is rough paper. The difficulty level of this problem is easy because you only need to know the very basics of elementary number theory, which is the greatest common divisor. So you need to know what that is, how we can compute this using recursion, or even if you don't know recursion to compute it, you should know the math behind the GCD function. So in this problem, we are basically given a rectangular sheet of paper. Now Sachin wants to divide this rectangular sheet of paper into some number of square sheets such that each square sheet has the same area and the square sheets divide the rectangle perfectly. So there should not be any leftover pieces in the rectangle and it should be perfectly divided into the minimum number of square sheets, each of which has the same area. Now the first observation from this problem statement itself is that we need to minimize the number of square sheets and each square sheet has the same area. This means that each square sheet has the same side length, and I'll get to the observation in a bit, but just remember that a square has the same area means that its side length should be the same for all the squares, and we need to divide this rectangular sheets into the same side length squares such that each side length basically fits within the rectangle, and we need to find out the minimum such squares to divide the rectangle into. So let's take an example. Let's say that the length is 4 and the breadth is 6. So in this case it's optimal for the side length to be 2, and hence the minimum number of square sheets will be 24 divided by 4 because the area of a single square is 4. The total area is 24, so 24 divided by 4 will give you 6. In the second example, it's optimal for the side length to be 5, and 10 into 15 divided by 25 will give you 6 again, because 10 into 15 is 150, divided by 25 is 6. So now I'll be explaining why we choose the side length to be 2 and why we choose the side length to be 5 in the first and second examples, and that lies in the key observation. So the key observation which I was talking about is that since we need to minimize the number of square sheets which we use, we need to maximize the side length of a square sheet. And the reason why we do this is because if you consider the total area of the rectangular sheet, that's equal to length into breadth, and if we choose a side length of a square sheet to be s, then the number of squares will be length into breadth divided by the side of the square, and that's because we know that each square occupies an area of s square and the total area should be l into b. That's why l into b divided by s square will give you the number of squares, and this basically means that in order to minimize the number of squares we need to maximize the side length s, and in order to do that we basically need to figure out a way for choosing a valid s. Now the key idea is that, so this is the first observation essentially, and the second observation is that is the constraint on the side length. So the actual constraint on the side length is that the side length should divide L and the side length should divide B, where L and B are the length and the breadth. And this is because if you consider the length, if you consider the full length, then you will realize that that basically we need to choose a value of s. Let's say that the side length is something like 10 for example, then a side length of 1 is fine. A side length of, so s can be 1, s can be 2 also, because that would mean that if s is 1 then there are 10 such things, 10 of them. If s is 2 then there are 5 such things, and basically each thing should have a side length of 2. And if s is 5 or s is 10, these are basically the divisors of 10. These are the factors of 10. So if you consider any factor of 10, you'll realize that only those factors of 10 are possible values of the side length, and any other value of the side length won't divide into the length, and since it won't divide into the length, it will basically not fit in the rectangular sheet completely, and it won't basically tessellate the entire rectangle. If you know what tessellation is, or it basically won't divide into the rectangle evenly if s does not if s is not a factor of L and if s is not a factor of B. So this basically means that s is a common factor of A and B both, of L and B both, and this basically means that since we want to maximize the side length, S should be the greatest common factor or the greatest common divisor of L and B both, and this basically means that S is the GCD of L and B. And you should pause the video and think about all the steps so far if you didn't get it fully. And basically then the final answer is very simple. We just use this equation which I've written over there. We just use the fact that the number of squares is L into B divided by S squared, and that's exactly what we'll print. So this is essentially a one-line solution. We just input the numbers and we print this value, and I hope you got the logic behind why this is true. Basically we are maximizing the side lengths, and since we are maximizing the side length which satisfies both the condition, it just turns out to be the greatest common divisor, and that's what we'll print. So I'll now show you the code which implements the same one-line idea. So in the C++ code for this problem, we need to make sure that we use long. If you use int, you'll get a wrong answer, most likely, because the values of the numbers can be very big, and if you square them, they'll definitely overflow. So that's why you should use long. And note that the time complexity is O of 1, that's why it will easily fit. 100 test cases will easily pass within 1 second. So in the C++ code for each test case, we will take an L and B. We will set the answer to be L into B, and we'll divide the answer by the GCD of L and B. We'll divide it twice, and we'll print the answer. And this is just another way of saying we are computing L into B divided by GCD of L into B, L comma B squared. And in the Python code, you can see this user has basically done the same thing. They take in the value of L and B, they compute the GCD to be N, and they print the value of L divided by N into B divided by N. And note that over here you need to use integer division. Again, you can get a problem if you don't use integer division, because in Python float is the default data type when you divide two numbers. That's why you need to do integer division, and we know that N divides both L and B. That's why you can do L into B integer division N squared, or you can separate them into two separate parts, L divided by N into B divided by N, and both the codes gets accepted. So I hope you like this problem and my solution. If you have any doubts, do leave them in the comments down below, and if you like this video, don't forget to give it a thumbs up. Thank you.